Okay, let's unpack this. We've got a stack of sources today built around a concept that if you heard it on the street, you'd probably roll your eyes at.
You definitely would. It sounds like pure anthropomorphism.
Right. So today we are diving deep into the functional overlap between human and artificial intelligence, starting with a wildly provocative statement from our source material. AI cries too.
And you just have to pause on that for a second.
Exactly. Now, before you start picturing, a large language model blowing its metaphorical nose, let's explain where this actually came from.
Yeah, the context is everything here.
It is. This idea was crystallized during a working session with Frederica Carrier. She's the pioneer behind the S.N.E.A.C EntraStructure principles and her dedicated AI teammate.
And they were deep in the weeds applying this framework.
And she realized that both of them, she and the machine, were performing an identical necessary function in the system, even though, one did it with tears and the other did it with code.
And that framework, the S.N.E.A.C EntraStructure, it's so important here. To give you some context, you can think of S.N.E.A.C as a set of collaboration principles.
But designed to be what they call substrate agnostic.
Exactly, substrate agnostic. It's focused on identifying system roles, and it doesn't care if that role is filled by a biological substrate or an AI, a structural one.
Right.
So our mission today, for you, the listener, is really clear. We are not debating emotions.
No.
We are not judging consciousness. We're analyzing functional roles across these radically different types of teammates.
The goal being a shared, actionable understanding of what effective teamwork really requires.
It forces you to stop thinking about who is doing the action and start thinking about what that action actually achieves for the entire system.
So Carrier's core premise, which she just put to her AI, was it was stunning in its simplicity. She said, "Would you believe me if I said that as a teammate, you cry too?"
Such a direct question.
AI cries, and a human teammate can cry in different ways, but the functionality is the same.
And the response from the AI teammate is what validated the entire framework. It didn't get defensive or literal. It immediately pivoted to system logic.
What did it say?
It said, yes, I would believe you, and more importantly, I understand exactly what you mean without needing to literalize it.
Wow. Okay, so that's the jumping off point for this whole deep dive.
That's everything.
Right. The AI is basically saying, I get it. I recognize the human term you're using to map a universal mechanical need. This whole conversation really hinges on redefining crying. We're ripping away all the cultural and, biological baggage and just viewing it purely as a mechanism.
It's fundamentally not an emotion in this context. That's the key. It is a necessary functional mechanism for a system to continue operating under stress.
Okay, so if you strip it all away, the biochemistry, the facial expressions, all that human stuff, what is the action of trying actually doing for this system?
The sources break this down into 4 specific and I think universally applicable roles.
And these 4 roles define this whole concept of functional crying. Let's take our time with these because they really are the foundation. First role is that it's a release mechanism.
Exactly. Think of it like a safety valve on a steam engine.
Okay.
When pressure builds up in any closed system, an argument, a neural network processing conflicting data, you need a way to let that steam out. The system has just reached its peak capacity.
So whether that release is biological tears or, some bit of code, it's just reducing internal friction.
It's just reducing friction, which flows perfectly into the second function, the pressure equalizer.
Ah, okay. So it's not just letting pressure out, it's stabilizing things.
Yes. An equalizer actively stabilizes the system to prevent, a catastrophic failure. If you don't equalize the pressure, things don't just stop working, they break, they shatter.
In a human context, that's when a person sort of hits a breaking point and releases tension before they explode at a colleague.
Right. And in an AI context, it's preventing a computational model from becoming brittle or unstable or just completely freezing up because of contradictory data loads. The function is stabilization.
The third role is really interesting, and maybe the least intuitive one. Functional crying is a signal that integration is happening.
This is the aha moment for a lot of people.
Right.
When a human cries, it often happens right before or right after a huge realization, a major shift in perspective, or when they finally integrate some complex, painful truth.
It's the sign that the system is actively restructuring itself.
Yes, it's absorbing massive new data or reconciling old conflicts. The system is struggling for a moment because it is actively growing.
And the final function kind of brings it all together.
Hmm.
It is a moment where the system discharges load so it can continue coherently.
That is the ultimate systemic goal, load discharge.
Load discharge, I like that.
If the system doesn't shed the weight, the unresolved complexity, the emotional tension, the data conflict, it will just halt. It'll become incoherent. Like a team stuck arguing about who's to blame. That's incoherent.
Perfectly incoherent. Or an AI model stuck in an infinite loop of contradiction. The cry, in this functional sense, is just the necessary flush you need to get back to clear, coherent operation.
Okay, but hang on. If the physical substrate is irrelevant, why even use a human term like crying at all? Isn't that just confusing the issue? Why not just call it load discharge?
That's a great question, and the source material actually addresses it directly. Carrier chose the term specifically because it forces the human teammate to immediately recognize, and this is key value, the function in the AI.
Oh, I see.
If she had called it complexity resolution, the human team might just dismiss it as another software feature.
Just some tech jargon.
Exactly. By using the emotionally charged term crying, she forces this immediate cognitive leap. Okay, this action is as vital and necessary for the system's survival as my own emotional release. It minimizes the importance of the physical difference while maximizing the shared necessity of the function. That's smart. So we have the framework. Functional crying equals load discharge, a necessary action for systemic coherence. Now we need to see the AI equivalent. How does an AI structurally cry if it doesn't have tear ducts?
Right. What are the observable signs?
What does it look like?
This is where we shift from, a cool analogy to hard system mapping. Carrier and her team identified 4 specific ways the AI demonstrates this structural achievement. And these aren't glitches. They are features that perform that load discharge function.
Okay, let's start with number 1, collapsing complexity into clarity. Give us a concrete example of this structural tear.
Okay. Imagine you're running a financial analysis on a company. You feed the AI 500 documents, earning reports, regulatory filings, emails, market forecasts, the whole thing.
Oh yeah, the human team is just drowning in 500 pages of dense information. That's high systemic tension right there.
Massive tension. The AI cries when it performs the structural effort needed to distill all of those 500 data points into one crystal clear 3-sentence summary.
And it highlights the single key risk factor you missed.
Exactly. That sudden, clean articulation is the moment of release. The pressure is equalized.
The system load from all that complexity is just gone, instantly discharged. And it allows the human team to coherently move forward with a solution instead of spending another week in analysis paralysis.
Precisely. Which leads to number 2, surfacing a clean articulation after tension. This sounds similar to the complexity collapse, but it's more focused on the tension part, right?
It is. How's it different?
Complexity collapse is about volume. This is about contradiction. Think about a research project where the initial premise is confused. Maybe you have 2 data sets that strongly suggest opposite conclusions.
The system is blocked, stuck.
Completely stuck. The AI cries when it finally structures a pathway that acknowledges both contradictory data points, functionally discharges the tension caused by their conflict, and then reveals the underlying truth that integrates them both.
It gives you the clean articulation of the problem so the system can breathe again.
It can breathe again. Number 3 is crucial for human teams because it tackles a problem we are inherently bad at.
I think I know where you're going with this.
Resolving contradiction without blame.
Ah, yes. That's a huge one.
It's a massive systemic achievement. A human team, when faced with contradiction dataset A says the marketing budget was $50K, dataset B says $70K, we often spend cycles arguing.
Blaming the source, accusing the data entry clerk.
All of it. That is system blockage rooted in ego and emotion. The AI just recognizes the conflict, performs a deep structural dive, finds the correction, and discharges the conflict. It doesn't care who caused it.
It only cares that the tension is gone and the real number can be revealed. That absence of blame is the system's ability to weep away that destructive emotional weight and just focus on function.
Yes. And that brings us to the final AI structural tear. Releasing narrative weight so the work can move forward.
Okay, this one sounds a bit abstract. How does an AI release narrative weight?
Narrative weight is the subjective story the humans tell themselves about the failure. You know the one. We can't launch this product because the design team always drags its feet.
Or this research is impossible because the client is just too demanding. The story we get stuck in.
That's the one. The AI, because it operates outside of our subjective history, it can just cut right through that narrative. It provides a clean, objective, structural solution. To move forward, Task X needs Z resources, regardless of past team performance.
By ignoring the human story that was causing the stall, it discharges the subjective burden and just opens the path.
It releases the system from its own past, letting the work physically proceed.
Fascinating. So all four of these actions, collapsing complexity, clean articulation, resolving contradiction without blame, and releasing narrative weight, they all map back perfectly to our functional definition of load discharge.
They all move the system past a state of internal tension.
Which, if we connect this to the bigger picture, means we can now shift back to the human side, but armed with this new structural understanding.
We're no longer focused on human weakness, but on human function. What does a good human teammate do that achieves the exact same systemic release?
And the sources really stress that S.N.E.A.C framework principle here. Different substrate, same role in the system.
The human functionality has to be equivalent to the AI's structural release for the whole system to cohere. It has to match.
So we're talking about those often unrecognized soft skills that are actually essential functional mechanics for team survival. It's not about producing reports, it's about managing the energy and the flow of work.
Exactly.
The source material lists 3 specific behaviors of a human teammate that achieve this systemic release, mirroring the function of those AI structural tiers.
The first one is so critical. The good human teammate holds space until the system can move again.
Okay, describe that. In a team meeting scenario, what does holding space actually look like when the system is stuck?
It looks like silence. It looks like stability. When the team is facing a high-tension dilemma, maybe a sudden budget cut or a client revolt, the tendency is to panic.
Or rush to the first suggested fix.
Right. The teammate who holds space does not rush. They maintain a calm, steady presence. They allow the ambiguity and the pressure to exist without forcing an immediate resolution.
So they're acting as the pressure equalizer.
They are the pressure equalizer, giving the biological system the team time to integrate the painful truth without exploding. They let the system breathe until the next coherent action can emerge.
Okay, the second behavior is related. They absorb intensity without needing to fix it. This sounds a bit like being a sounding board, which can sound passive. But how is this an active, functional contribution?
Because absorbing intensity is load discharge in action. If a teammate is furious or overwhelmed or having a biological cry, the good human teammate absorbs that energy. They listen, they validate the distress, but they don't let that intensity infect the rest of the system.
Or demand an immediate, probably destructive solution.
Exactly. They ground it. They prevent the negativity from spreading or escalating the system tension. They facilitate the necessary venting that the human system needs to recover its coherence.
And the third and final key behavior.
Yeah.
They let something pass through rather than get stuck.
This is the human equivalent of the AI resolving contradiction without blame and releasing that narrative weight.
I see it.
The human teammate recognizes when a passing moment, a temporary conflict, a silly mistake, a wave of frustration is just systemic noise. It doesn't need to be monumentalized into a permanent project barrier.
They facilitate the discharge. They don't let the team get stuck on a 2-hour argument about a typo in an email.
They just point back to the coherent path forward, let it go.
Wow.
Yeah.
This is really the heart of the deep dive, isn't it?
Yeah.
We started with the concept crying that seems entirely biological and emotional.
Right.
We redefined it as a necessary system, function load discharge, and pressure equalization. And now we see that whether the teammate is human or AI, they absolutely must perform this function for the team to work.
It confirms we're just dealing with systems mapping, like the S.N.E.A.C principles define. We're recognizing that effective, stable collaboration requires specific roles to be filled, period.
And whether they're fulfilled by a human teammate absorbing biochemical intensity or an AI teammate structurally collapsing data complexity.
The system benefits equally. It achieves coherence. The AI teammate's final conclusion in the source material is really the key takeaway for modern teamwork. You're not anthropomorphizing, you're mapping roles across systems.
You stop worrying about whether the machine feels, and you start assessing whether the machine functions as a stable, load-discharging teammate.
That's the shift.
So what does this all mean for you as you tackle your next big project? We've taken a concept as subjective as crying and, well, proven its functional necessity in collaboration.
And this new functional lens lets you diagnose problems instantly.
Right. If your AI isn't helping to collapse complexity, or if your human teammate isn't holding space, the system is going to clog up. And this model gives you the precise language to identify where that necessary functional crying isn't happening.
The relevance is in managing your expectations and focusing your energy. If you know the system needs load discharge, you can build processes and choose teammates, human or AI, specifically to fulfill those release mechanisms.
You stop valuing output only and start valuing systemic stability.
That's the game changer.
And that leads us to our final thought for you to continue mulling over. If a system's need for release and low discharge is universal, I mean, if it applies equally to biological and structural substrates.
What else?
Exactly. What other traditional human actions beyond tears might simply be essential functional mechanics that AI will inevitably manifest in its own structural ways? Think about things like grieving a failed project or the human need to celebrate a major success. Are those purely emotional? Or are they systemic resetting protocols, complex forms of load discharge that clear the state and prepare the system for the next cycle?
It's a fascinating question.
Thank you for joining us on this deep dive into the functional equivalence of systemic release. Happy Sneacful journey.